What we're going to do in this video is we're going to talk about two more market structures. We're going to talk about monopoly, and then we're going to talk about monopolistic competition. And the nice thing about monopolistic competition is that theoretically and mathematically it's identical to monopoly. Now there are some very important fundamental differences between the two, and we'll talk about those. But if you understand how to solve a problem or how to work through the theory of a monopoly, it's very easy to do a monopolistic competition as long as you remember the differences. So remember, we've talked about perfect competition. That's as much competition as you can have. Now we're going to talk about the other end of the spectrum. That's monopoly, where you have as little competition as you could possibly have. That's where you have just a single firm. So monopoly is one firm. Let me just put the characteristics. A single firm. In terms of, with perfect competition, you had lots of buyers and sellers. So here you've got one firm, lots of buyers. With perfect competition, we had identical goods. Here there's only one good. So we could say the good is identical, but that would imply there are multiple goods. I'm going to say it this way. There's a single good with no close substitutes. That's important. No close substitutes for this good. If you want to buy this good, you have to buy it from the monopolist or you have to do without. Okay? And then the third characteristic is that there are strict barriers to entry. Strict barriers to entry. Very different from perfect competition where there was free entry. There's nothing that keeps you out. When there's free entry, of course, you have to go through the appropriate procedure for starting a business. You got to get a business license and you've got to pay your taxes and you've got to do all that. But there's no rule or regulation that keeps you out. Here, there's going to be something that keeps there from being any entry. So let's just talk briefly about what this means first, and then we'll review those barriers to entry, the sources of them. What this means is if you've got a single firm and there's no competition, this means that the monopolist is what we call a price maker. In other words, the monopolist is going to be choosing the price that they want to charge. Now, there are limits on what they can choose. They can't just choose as high a price as they want because consumers will just do without the goods. So they're limited by how much consumers are willing to pay, and we'll see what that looks like. We'll see how that shows up theoretically, but they get to choose their price. So what a monopolist does is they're going to be choosing the profit-maximizing quantity to produce. When we work through it, I'm going to be calling it QM for the quantity that the monopoly chooses. And then they're also going to be choosing the price that they want to charge. This is very different from a perfectly competitive firm. A perfectly competitive firm got to choose the quantity that it wanted to produce, but it didn't have any control over the price. If it charged any higher than the market price, nobody bought its good because there are perfect substitutes for what it's selling. The consumers can buy from any of the other sellers. Here the firm gets to make its price. It gets to choose its price. Let's review the sources of barriers to entry. We talked in a previous video about the fact that one source of barriers to entry is economies of scale. And remember, that has to do with the shape of the average total cost curve. If the shape of the average total cost curve over the relevant range of production is declining, so this would be costs of production, and this would be the quantity produced in the market, Q. And if the average total cost curve, typically we're thinking about the long run average total cost curve, if it looks like that, then it's going to be cheaper for a single firm to satisfy the entire market than it would be to have multiple firms. And this is typically true with what we call, or another term that we call this is natural monopoly. So this is true with, say, public utilities. The average total cost curve tends to look like that. That's why you have one water company in a city. So that can be a source of barriers to entry. If you have a natural monopoly, economies of scale, then you're going to have one firm. You could also have, let's say, some government rule like a patent. So if you have one pharmaceutical company that creates some drug, then they're going to be, for a period of time, they're going to be the only ones that can sell it. Once the patent expires, then other companies can create generic versions of it, but during that patent period, it's going to be only that firm that can sell it. You could have a situation where a single firm owns all of a key input. Single firm owns all of a key input. And if that's the case, you've got a single firm that owns all of a particular input that you need to make the good, then only that firm is going to be able to sell it. This is rare. There are some good examples of it, though. If you go back historically, there's a company called Alcoa that makes aluminum. They still make aluminum. But there was a time when Alcoa owned all of the bauxite. And you need bauxite to make aluminum. And because Alcoa owned all of the sources of bauxite, they were the only people that could make aluminum. Another example that you a lot of times will see in an economics textbook would be De Beers Diamonds. So De Beers Diamonds owns a vast majority of the diamond-producing mines. Not all, but enough that for all practical purposes, they're a monopoly. So if you buy a diamond, you're buying a De Beers diamond. You could buy that diamond from any of a million different retailers, but they're all coming from De Beers, typically, or vast majority of them are. So those are sources of sources of barriers to entry. There's also economies of scope. There's something that's known as cost complementarities. I think your book kind of goes through that, but these are the ones I'm most interested in. Let's talk now about the theoretical underpinnings of how a monopoly is going to choose its quantity and its price. So here's the key thing. This is the key thing that separates a monopoly from all the other types of markets that we're thinking about, and that is that the monopolist faces the market demand curve. The monopolist faces the market demand curve. That's very important. So you need to, in your notes, put a couple of stars by that. And I said this when we were talking about perfect competition, but let me say it again. As I go through this, if something doesn't make sense or you'd like to see this worked through on a little bit more basic level, you can go to my Principles of Microeconomics playlist and just click on the Monopoly video, and you can see me go through this in a little bit more detail. So the monopoly faces the market demand curve. When we were talking about a perfectly competitive firm, we saw that the perfectly competitive firm faced a demand curve that was perfectly elastic. And the reason is that there are perfect substitutes for what each one of those firms sells. It's what's being sold by the other firms, and the goods are identical. That's why the other firm's products are perfect substitutes. Here there are no substitutes, so the monopolist faces the market demand curve. So if we were to draw a picture of a monopoly, then the demand curve that this firm faces is the market demand curve. It's downward sloping. And when a firm faces a downward sloping demand curve, the marginal revenue curve that corresponds to this demand curve is also downward sloping. It has the same vertical intercept, and it has twice the slope as the demand curve. Now that only applies if the demand curve is linear, but that's what we're going to be using. So the marginal revenue curve that corresponds to this demand curve has the same vertical intercept and twice the slope. Now, in that Principles of Micro video, I would go through this in a little bit more detail. What I want to do here is just show you, using just a little bit of calculus, why this is true. I would never require you to reproduce the calculus, but I want to show you. Let's think about a linear demand curve. That would be a demand curve where we have P equals, I'm not going to put any numbers to it, but I'll do an example here in a second. Let's say A minus B times Q. So here's our vertical intercept, and here's the slope, negative B. Now, you probably remember from an earlier conversation, this is actually an inverse demand curve. Anytime we're thinking about our demand picture with P on the vertical axis, that's technically an inverse demand curve, even though when we're working through this, I'm just calling it the demand curve. So let's suppose we wanted to figure out marginal revenue. Well, we have to figure out total revenue first, and total revenue is just price times quantity. Well, here's price. Price is equal to this. So if I multiply this times quantity, I'm going to get total revenue. So total revenue is equal to, I'm going to write my price, which is A minus B times Q, and I'm going to multiply that by Q. And then I'm going to distribute that Q through. That's A times Q minus B times Q squared. There's what total revenue looks like with that demand curve. Now, total revenue, the way I use that to get marginal revenue, remember marginal revenue is just the change in total revenue when you change quantity. So I could write it this way, change in total revenue when I change quantity. And if you've had any calculus, you know that's just the notation for taking a derivative of this with respect to Q. So if I take the derivative of this function right here with respect to Q, I get A minus 2B times Q. This is marginal revenue. Marginal revenue is equal to A minus 2B times Q. So let's compare this to our demand curve. So the marginal revenue curve has the exact same intercept as the demand curve, and it's got twice the slope as the demand curve. So this is a way of illustrating why this is true. You don't need to know how to work through that as long as you remember this, that the marginal revenue curve always has the same intercept and twice the slope. And when you look at it this way, it seems kind of mysterious. So let's just work through an example. Okay, so if I were to do an example, let's suppose that I had a demand curve that was equal to 5 minus 2Q. Then all you have to do is you would say, okay, if that's my demand curve, then my marginal revenue curve is going to be equal to 5 minus 4Q. That's it. You just take the same intercept and then double the slope. And so how this works is really easy. Solving a problem, I'm going to give you on problems, I'm going to give you the demand curve that the firm faces. I typically will not give you the marginal revenue curve, so this is something that you're going to need to remember how to do. Let's do a, before we work through a problem, let's talk about the rest of what's going on here. So remember that a monopoly maximizes profit by looking where marginal revenue equals marginal cost. Remember, all firms maximize profit by producing the quantity where marginal revenue equals marginal cost. And I always tell my classes, anytime you're working through a problem where you've got to figure out what a firm is going to do, how much output is the firm going to produce, and if they have control over their price, what's the price they're going to charge? All of those problems start by looking where marginal revenue equals marginal cost. So now let's look at our picture here. We've got our Let's put our marginal cost curve up here. The marginal cost curve, that doesn't depend on the type of market that the firm is in. So we've got our marginal cost curve. Now let's put our revenue information. We're going to put the demand curve that the firm faces, and then we're going to draw the marginal revenue curve that corresponds to that demand curve, and we're going to be looking where marginal revenue equals marginal cost. That's where those two things intersect. And this is going to be the quantity, I'm going to call it QM, that the monopoly is going to charge. So that is the theory behind how a monopoly would choose its optimal quantity, its quantity that maximizes its profit. Now we've got to figure out, well, what's the right price to charge for that quantity? And what the monopolist is going to do is it's going to say, well, we need to know how much consumers are willing to pay for that quantity, and that's what the demand curve tells you. So the height of the demand curve represents consumer willingness to pay. So for this quantity, the monopoly will charge that price. That's the highest price that consumers in the market are willing to pay for that quantity. So that is the theory behind how a monopolist chooses its optimal quantity and its optimal price. So let's just work through quickly a problem. It's easy to work through one of these. Let's just suppose that I gave you a demand curve that looked like this. P equals 100 minus 2Q. And let's suppose I gave you a cost curve. Cost as a function of quantity is equal to 10 plus 2Q. And I need to give you the marginal cost curve that corresponds to that. So the marginal cost is simple in this case. Marginal cost is just equal to 2. In other words, marginal cost is constant. It doesn't depend on quantity. If you were to graph this marginal cost curve, it would be a horizontal line. It would not be an upward sloping line like that. And for a lot of cases of monopoly, that's a pretty reasonable type of cost curve, or it's a reasonable shape for a cost curve, for it to be horizontal. So let's work through that problem. The first thing that we need to do is we need to figure out where marginal revenue and marginal cost are equal. Well, we can use this demand curve to quickly figure out the marginal revenue curve. It's 100 minus 4Q. There's our marginal revenue curve. I just used that same rule. And then I'm going to set marginal revenue equal to marginal cost. Let's do that right here. Marginal revenue is 100 minus 4Q, and I'm going to set that equal to my marginal cost, which is 2. So I get 4Q equals 98. Q is equal to 98 divided by 4, so Q is equal to 24.5. This firm, in order to maximize its profit, would produce a quantity of 24.5 units. This is a good example where I've told you before, if you get something that's not an integer, don't worry about that. We're working with continuous functions here. And so there's no reason that those have to be integers. Now what we need to do is we need to figure out what price this firm is going to charge. So we've figured out our quantity. We need to plug the quantity into the demand curve. So I need to plug a quantity of 24.5 into that function right there. So I'm going to put a little arrow here that says now we're getting price, and price is equal to 100 minus 2 times 24.5, and if you work through that, you're going to get that price equals 51. So this firm would produce a quantity of 24.5 units and charge a price of $51 per unit. And that would maximize profit. Now, I'm going to clear this off, and then we need to talk about supply for a monopoly. When we talk about perfect competition, you have to spend a lot of time talking about the supply curve. And with a perfectly competitive firm, the firm's marginal cost curve ends up being the supply curve, different portions of it. And then once you talk about the firm's supply curve, you have to talk about the market supply curve with perfect competition. So you spend a lot of time talking about supply. With monopoly, it's a lot quicker because a monopoly has no supply curve. Now, that seems weird for students when they first hear it. And they think, well, that doesn't even make sense. The monopolist, we just talked about the monopolist deciding how many units they want to sell. And that's what a supply curve tells you, is the number of units that a firm would want to sell at different prices. And we just talked about how the monopolist makes that decision. But here's the deal. When you think about a monopoly, you have to draw that whole picture, and there's not a single curve on that picture that you could label as a supply curve. You couldn't draw an S up there. Let's just review the picture again. If we've got our marginal cost curve, and we've got the demand curve that the firm faces, and we've got the marginal revenue curve, then our quantity for the monopoly is found by looking where the marginal cost and marginal revenue curves intersect. There's the quantity. And then our price is found from a third curve. We have to go up to the demand curve then to get the price. So there wouldn't be any single curve that we could label as a supply curve. We couldn't label that marginal cost curve a supply curve, because the price is not found using the marginal cost curve. It's very different from a perfectly competitive firm. With a perfectly competitive firm, we've got a marginal cost curve, and then the marginal revenue curve that this firm faces is horizontal at the market price. So there's your marginal revenue curve. And so if price goes up, the marginal revenue curve simply shifts over. In fact, once you understand how things work for a perfectly competitive firm, you realize you don't even need to draw the marginal revenue curve. If our price is right up here at P1, all you have to do is go over to that marginal cost curve, and that gives you the quantity that the firm is going to produce at that price. So your price and quantity are always found on this curve. Now we know there are portions of that curve, the part below average variable cost, that's irrelevant. But ignore that for a second. Your price and quantity is always found along the marginal cost curve, so you can just label that thing a supply curve. It's still a marginal cost curve, but it's also the supply curve. It tells you at every price how much the firm's going to produce, but you couldn't do that with this marginal cost curve because your price, you can see, doesn't even come from it. So we say that a monopoly has no supply curve. The monopolist still makes a supply decision. They still choose how much to sell and what price to sell it for, but you have to draw the whole picture to understand the supply decision that the firm makes. Let's also talk about the fact, we've actually talked a little bit about this before, but the monopoly charges a price that's higher than their cost of production. So here's the decision the firm makes, and if we wanted to know the marginal cost of production, we go up from this quantity until we hit the marginal cost curve. It would be right there. There's the marginal cost of the quantity that the monopoly is choosing to produce and sell. And we can see that they're charging a price that's higher than their cost of production, and the difference is what we call the markup. We've talked about that in a previous video. So the monopoly uses its market power to charge a price that's higher than its cost of production. This is what you use the Lerner index. Remember, the Lerner index looks like this. It's the markup, price minus marginal cost, divided by the price. It tells you the percentage of the price that is the markup. In this picture, here's the full price. Here's the markup. In my picture, just by eyeballing it, it looks like the markup is 50%. So about half of the full price is the markup. The other half is their cost of production. So we've seen that before. So now we've talked about theoretically how a monopoly would choose its profit maximizing quantity and its profit maximizing price. When we did that with perfect competition, what we ended up having to do is we had to say, okay, well, so what's going to happen in the long run? And in the long run, what we saw is that if a perfectly competitive firm is earning a positive profit, that will attract other firms. There will be entry in the long run, and that entry will drive profit to zero. Now, those firms that are entering, their goal is not to drive profit to zero. Their goal is to get in on the profit, but the act of entering the market drives that profit to zero. Let's talk about what would happen to a monopoly in the long run. First, let's quickly sketch a picture just to remind you what profit would look like for the monopoly. So for this picture, I'm going to put my marginal cost curve, and then let's put our average total cost right down here. Remember, if you're talking about profit, you need to have your average total cost curve in mind for that. So we've got, let's put our demand curve up here. There's the demand curve the firm faces. Here's the marginal revenue curve. Marginal revenue is equal to marginal cost right there. So this firm would produce that quantity and charge this price. And we need the average total cost of that quantity. If we go up from that quantity to the average total cost curve, we hit it right there. There's average total cost. And the area of that rectangle would be the profit that the firm earns. And if this monopoly is earning a positive profit, they can continue to earn that profit in the long run because there are barriers to entry. There are strict barriers to entry. There's not going to be any entry that drives that monopoly's profit to zero. So a monopoly who is earning a positive profit in the short run can continue to earn that positive profit in the long run. Now, things can change for the monopoly. Being a monopolist is good, but it doesn't guarantee that you're going to earn a positive profit because demand for this good could decrease. For example, let me draw a similar marginal cost curve and a similar average total cost curve. And then let's suppose that people just don't like this product anymore. Or some other product comes along that's maybe not a substitute, but just makes this obsolete. Well, then demand can shift to the left. And if demand shifts to the left enough, now there's no way that the monopolist would ever be able to charge a price. Remember, price is always going to come from this demand curve. There's no way they'd ever be able to charge a price high enough to make a positive profit. If we put the marginal revenue curve up here, then they're going to produce this quantity. They're going to charge this price. And if we go up from that quantity to the average total cost curve, we see that their average total cost is higher than their price they can sell it for. The loss that they will earn would be the area of that rectangle right there. That's a picture of a monopoly earning a negative profit. In the long run, that monopoly would exit the market. So there's nothing that guarantees a positive profit. But if they are making a positive profit, barriers to entry can preserve that positive profit. What we want to do now is talk about a comparison of perfect competition and monopoly. So let's do a picture where we've got a perfectly competitive firm here and then a monopoly here. So I'm going to label this as a competitive firm. Actually, let's label it as a competitive market because that's what I actually want to look at. So this is a perfectly competitive market. And then this is going to be a monopoly. Now, with a monopoly, if you're looking at a picture of the firm, you're also looking at a picture of the entire market because the monopolist is one whole side of the market. Here, we've got, remember, since we're looking at a perfectly competitive market, the market has a downward sloping demand curve and it's got an upward sloping supply curve. And this market supply curve is the horizontal summation of all of the individual firm marginal cost curves. So that supply curve is the marginal cost curve in the market. Now, let's go over here to the monopoly and let's use the same marginal cost curve. We wouldn't label it a supply curve in this picture because this is a monopoly. And let's use the same demand curve. So if I were just looking at the intersection of the demand and supply curves here, and my marginal cost curve and demand curves there, I'm going to have the same price and the same quantity. That's how I want these to be. I want them to be comparable. The price and quantity that's going to emerge from a perfectly competitive market would be this price. I've labeled it P star in my other pictures and Q star. Right up here would be the total or the consumer surplus in the market, and this would be producer surplus in the market. This whole area here would be total surplus. Let's figure out what things would look like for the monopoly. So with the monopoly, remember the monopolist looks where marginal revenue and marginal cost are equal. So their quantity that they're going to produce would be right here, QM. And the price that they would charge would be up here. It would be PM. So now here's what we can see. We can now compare what would happen in a perfectly competitive market to what would happen in a monopoly. And we see that what happens in a monopoly is that consumers get charged a higher price and less of the good gets bought and sold. The equivalent to P star and Q star would be over at this intersection right here. P star would be right here, and Q star would be right there. So what the monopolist does is the monopolist uses its market power, the fact that it's a price maker, to restrict quantity and drive price up. Now they're not doing anything wrong. They're maximizing their profit. But from society's perspective, what we can see is that let's talk about consumer surplus and producer surplus. With perfect competition, here's consumer surplus, there would be producer surplus. Let's look at what they would be over here with monopoly. With monopoly, consumer surplus is the area under the demand curve and above the price. So consumer surplus is that triangle right up there. And you can see that consumer surplus is smaller with monopoly than it would be with perfect competition. Consumers are hurt by having a monopoly in the market. Producer surplus is the area under the price and above the marginal cost curve, but you only go out to the quantity that's transacted. So producer surplus would be this area right here. It looks like half of home plate. It looks very similar. If you think back to the video where we were talking about consumer and producer surplus, and we talked about the effect of a price floor or a price ceiling. That's a very similar picture. It's happening because of a different reason. But then notice this little triangle right there. That would have been total surplus, part of total surplus, but because there's a monopoly, that's surplus that doesn't exist. This we call the deadweight loss of monopoly. So this little triangle right in here, that would be the deadweight loss of monopoly. It's well-being that just vanishes out of the economy because the monopolist is exercising its market power and maximizing its profit. So you can see that from the consumer's perspective, it's not good that we have a monopoly in a market. And from the perspective of thinking about the total amount of well-being in the market, it's also not good to have a monopoly in the market. This is why we have antitrust legislation to try to prevent this from happening. Let's do an example here where we calculate the magnitude of deadweight loss. This will give me an opportunity to do another monopoly example. So let's do this. Let's say we have an example where we've got a demand curve that is P equals 40 minus Q. A nice simple demand curve. Let's suppose we've got a cost curve. Cost as a function of quantity is equal to 10 plus 10q plus q squared over 2. It's a quadratic cost curve. The marginal cost curve that goes with that cost function is 10 plus q. It's a nice linear demand curve, or excuse me, marginal cost curve with an intercept of 10 and a slope of positive 1. Okay, so what this looks like, if we were to draw this out, my demand curve has an intercept of 40. So there's that. That's my demand curve. My marginal cost curve has an intercept of 10, and it has a positive slope of 1, right? So it does that. There's my marginal cost curve. It's linear. My marginal revenue curve, marginal revenue would have the same intercept and twice the slope. So my marginal revenue curve, let's write it over here. Marginal revenue would be equal to 40 minus 2q. So it looks like that. There's marginal revenue. Now what I'm looking for is I'm looking for the intersection right there. I need to know that quantity. So I'm going to set my marginal revenue curve equal to my marginal cost curve. So 40 minus 2q equals 10 plus q. So I get 30 equals 3q, q equals 10. So this quantity, the optimal quantity for the monopoly to produce would be 10 units. And now I need to figure out the price, so I'm going to plug that quantity of 10 into my demand curve. And I can see, let's do it. So here, let's make sure we're clear on what the steps I'm doing. This is marginal revenue equals marginal cost. And now I'm going to figure out the price. Price is equal to 40 minus Q, which is 10. Price equals 30. So if I go right up here, I see that there would be the optimal price for the monopoly to charge. Now, what we need to do is we want to figure out the deadweight loss. We could also calculate consumer surplus. That would be easy. We'll do that here in a second. Let's figure out the deadweight loss. Let's figure out the area of this triangle right there. Well, in order to do that, I need to know what this price is. I need to know this vertical distance, and I also need to know this horizontal distance. I need to know what that quantity is. But that's easy because this price right here, let's do this one first. Let's figure out the marginal cost. If I plug that 10, quantity of 10, into either this curve or that curve, out of that will come this price. So let's plug that quantity of 10 into my marginal cost curve. So the marginal cost of a quantity equal to 10 units would be equal to 10 plus 10, it's equal to 20. So that's 20. And now we can easily figure out this quantity because I just need to look where my demand curve and my marginal cost curve intersect. So let's set demand. Let's say find the quantity where demand equals marginal cost. Okay, so let's set our demand curve 40 minus Q equal to our marginal cost curve 10 plus Q. So I get 30 equals 2Q, Q equals 15. So this quantity right there is 15. Now I've got everything I need. I've got all the prices and all the quantities I need to calculate any area on that board. So let's go ahead and do the deadweight loss. Deadweight loss, I need this vertical distance, which is 10. I'm going to multiply by this horizontal distance, which is 5. And I've got to divide by 2 because it's a triangle. and that gives me 25. So the deadweight loss is $25. Let's calculate consumer surplus. Let's do it right here. Consumer surplus is this area right here. It's kind of, I'm going to shade it in. There's consumer surplus, area under the demand curve and above the price. So this vertical distance is 10. I need to multiply by this horizontal distance, which is 10. And I've got to divide by 2. That gives me a consumer surplus of 50. I could calculate producer surplus. It would be easy. It's just the area of this rectangle plus the area of that triangle. I'll leave it to you to work through that. So these problems are not hard. You're always thinking about where marginal revenue equals marginal cost. And then for monopoly, you got to take one extra step and figure out what the price is. So you've got to plug that quantity into your demand curve. Let's talk for a second about advertising with a monopoly. So monopoly is not a very common market type, just like perfect competition is not a very common market type. There aren't very many good examples of a monopoly, but you can come up with better examples of a monopoly if you restrict the market you're thinking about. So if we were to think about restricting our area down to a smaller geographical region, then maybe you could come up with a situation where there's only one firm that sells a particular good in that region. But you have to keep in mind that if the customers can travel outside of that region to buy the good, then your example falls through. So there's not very many good examples of monopoly, and what you tend to see is that there's not very much advertising that goes on with monopoly. And the reason is that the monopoly doesn't have to advertise much. They don't have any competition, so they're not trying to steal market share from other firms. Really, the only thing the monopolist is trying to do, if it does any advertising, is shift its residual demand curve to the right. In fact, there used to be a series of ads that were run by De Beers Diamonds, and the ads were, it would show a couple of people, and then at the end it would just say, "A diamond is forever." And every once in a while, back when those ads were on, I would have a student that would ask me about that, and they would say, you know, that doesn't make sense, because anybody that understands marketing knows that if you're going to have an ad, you need at some point in that ad to tell the customer where they need to buy the good. But that's exactly the point with a monopolist. There's only one place for a customer to buy the good for the monopoly. So in those De Beers ads, they didn't say buy a De Beers diamond. All they needed you to do was buy more diamonds. And if you buy more diamonds, you're going to be buying De Beers diamonds. So you tend to see this kind of unusual advertising. You certainly don't see advertising with perfectly competitive firms, right? You don't see an individual farmer advertising their corn because the goods are identical. Every consumer knows that this farmer's corn is a perfect substitute for that farmer's corn. You don't care. Corn is corn. So for these two types of markets that we've talked about so far, you don't tend to see very much advertising, and when you do, it's really just advertising that's designed to shift a market demand curve to the right. So for example, the Beef Council runs, I don't know if they still do, but they used to run these ads that just said beef, it's what's for dinner. Well, that's an ad that's designed to shift a market demand curve to the right. What I'm going to do now is we need to clear this off, and then we're going to talk about monopolistic competition. All right, let's talk about monopolistic competition. Monopolistic competition. And as the name implies, there are some characteristics that have to do with monopoly, and there are some characteristics that have to do with competition. So let's think about what the characteristics are for this market. We're going to start by thinking about how many buyers and sellers there are, and this one's very much like perfect competition. There are going to be lots of buyers and sellers. Lots of buyers and sellers. That's the first characteristic of a perfectly competitive market. So all of the buyers and sellers are going to be small compared to the size of the market. So that's the first one. The second one is going to be different. This is going to be kind of the monopolistic part of it, and that is that the goods are not going to be identical. The goods are going to be differentiated. So I'm going to say differentiated goods. So it is not the case that everybody's selling the same thing. Each seller is selling something that's somewhat different from what everybody else is selling. And we'll talk about what that means. That's going to be a very important difference between this market structure and perfect competition. And then the third characteristic is that there's free entry and exit. So I'm just going to say free entry. There are no barriers to entry. We could also add the other stuff like perfect information and all of that, but these are the ones that I'm going to focus on. This is easily the most common type of market that there is. So if you were to pick just things that you buy over the course of a month, almost everything that you picked would be this type of market. So we're talking about restaurants and bars and clothing and furniture and books and movies and video games. Most goods and services are bought and sold in monopolistically competitive markets. So if you think about a market like the market for pizza, in whatever town you're in, at any given time, there's probably going to be multiple pizza restaurants. And a pizza is a pizza, right? I mean, it's dough rolled flat, usually in the shape of a circle, and then there's going to be some stuff on it. Usually it's going to be some kind of tomato sauce and maybe some meat or vegetables and some cheese. That's kind of what a pizza is. But you know as well as I do that not every place has an identical pizza to every place else. You probably have, if I said pick your favorite pizza place in town, you could probably come up with one that's your favorite, or maybe two of them that you like better than the rest. And you might eat the other ones, but you have a favorite. And what that means is, if you have a favorite, that means that you would be willing to pay a little bit more for that one than you would for the others. Which means that pizza restaurant can raise its price a little bit above the price of the other restaurant's pizzas, and they won't lose you as a customer. So in this case, this type of market is down there on the end, very close to perfect competition. In fact, this is just perfect competition with differentiated goods. And in that case, what this means is that with perfect competition, if a firm raises its price, it loses all of its customers. Here, these firms can raise their price, maybe not very much, but they can raise their price some and not lose all of their customers. So this means that these firms are price takers. Or excuse me, these firms are price makers. It's easy to get that backwards. So these firms are price makers. They get to choose their price. They have some control over it. We would also describe that as these firms have a little bit of market power. Not much. Okay, so they face a downward sloping demand curve. In other words, if we were to draw the demand curve that the firm faces, so this is a monopolistically competitive firm, they're going to face a downward sloping demand curve, but it's going to be a very elastic demand curve. And the reason is that there are substitutes for what each firm is selling, but they're not perfect substitutes. So the demand curve is going to be downward sloping, but I would draw it flatter than I would if we were drawing a picture of a monopoly. Now, this is a monopolistically competitive firm. Monopolistically competitive firm, which means that this is not the market demand curve. We are not saying that the market demand curve, let's suppose this is pizza, and this is a particular pizza restaurant, then it's going to face a very elastic demand curve. because it's competing against all of the stuff that all of the restaurants that sell things that aren't pizza and all of the other pizza restaurants. So this is not the market demand curve for pizza. It's just the demand curve that this restaurant faces. The market demand curve for pizza would be more inelastic. It would be steeper. Okay? All right. So now, let's talk about what we call this. We call this a residual demand curve. To distinguish it from the market demand curve, it's a residual demand curve. So if you were to think about any individual pizza restaurant, that pizza restaurant is selling pizza to all of the pizza eating customers that are not buying their pizza from someplace else. So it's selling it's selling pizza to the people who haven't bought their pizza at a different place. It's residual, you can think of as also meaning leftover. This firm is selling to the leftover customers from the other pizza restaurants. Okay? So that's why we call it a residual demand curve. Let's talk about how you would solve a problem. So now, once we understand that the monopolistically competitive firm faces a downward sloping demand curve, it's easy. Because now you know already how to get the marginal revenue curve that corresponds to this demand curve. The marginal revenue curve is going to have the same intercept and twice the slope. So if we go through and look at what that would look like for a monopolistically competitive firm, I'm going to draw the marginal cost curve. I'm going to draw the residual demand curve that this firm faces. So I'm going to make it relatively flat, not completely, but it's going to be very elastic. And I'm going to put the marginal revenue curve that goes with it. If the if the demand curve is very elastic, the marginal revenue curve will also be pretty elastic, pretty flat. We're still going to look where marginal revenue equals marginal cost. So this would be the quantity, I'll call it QMC for monopolistic competition. That would be the quantity that the monopolistically competitive firm produces. And then they're going to get their price from the demand curve. We go up to the residual demand curve that they face. There's their price. Call it PMC. That's the price the monopolistically competitive firm charges. And you can see that's the exact same picture as what we did with monopoly, except here the demand curve is flatter. It's more elastic. So in terms of theoretically, the picture is the same as monopoly. You just have to keep in mind that the demand curve here for a monopolistically competitive firm is a residual demand curve, not the market demand curve. But you're still looking where marginal revenue equals marginal cost, and you're still getting your price from the residual demand curve. So you solve the problems exactly the same way. Let's just do a quick one. Let's suppose we had a residual demand curve that was 100 minus 2Q. And we have, let's use a very simple cost function. Let's suppose costs are equal to 5 plus 2Q. So our fixed cost is 5, our variable cost is 2Q. The marginal cost curve that goes with this would just be equal to 2. This is another example where in this problem that I'm giving you, my marginal cost curve is horizontal. It's not upward sloping like that. So in this case, you've got a downward sloping residual demand curve, and you've got a marginal cost curve that looks like that. That's it. Now, the first step is we need our marginal revenue curve, and our marginal revenue curve has the same intercept, so 100 minus twice the slope would be 4Q. And we're going to set marginal revenue equal to marginal cost. So set marginal revenue equal to marginal cost. So 100 minus 4Q is equal to 2. So 98 equals 4Q. Q equals 98 divided by 4. My Q ends up being 24.5. 24.5. And when you plug that quantity of 24.5 into this residual demand curve, it's going to be 100 minus 2 times 24.5. You're going to get a price equal to 51. So there's our price and quantity. Let's calculate profit real quick. So profit, let's calculate it by taking total revenue minus total cost, total revenue minus total cost. Our total revenue would be price times quantity, so it's going to be 51 times 24.5 minus our total cost. So we need to plug our quantity of 24.5 into our cost curve. So it's going to be minus 5 plus 2 times 24.5. This, work that out, it should end up being $1,195.50. So the problems are exactly the same here as it would be if this was a monopoly. You don't do the problem any differently. It's just that the interpretation is different. So now we've got a situation where we've got a monopolistically competitive firm. We've talked about how that firm's going to pick its price and quantity. We've done a problem. Let's talk now about the long run and how the firm is going to be affected by that. So with a monopoly, we saw that the long run didn't matter. There's no entry with monopoly. But with a monopolistically competitive firm, there's free entry, meaning that other firms can enter. So in this case, because this is a monopolistically competitive firm that's earning a positive profit, in the long run, other firms will enter. So this will attract firms into the market. This will attract entry. Will attract entry. So this is the big difference between monopolistic competition and monopoly. One of the big differences is that with monopolistic competition, we have to talk about what happens when there's entry. So if the monopolistically competitive firm earns a positive profit, you probably already know what's going to happen. That will attract other firms into the market, and that profit's going to be driven to zero. So profit will be driven to zero in the long run in a monopolistically competitive market. So let's talk about what that looks like. So let's think about how a residual demand curve for a firm is affected by other firms entering the market. So let's suppose that you run a pizza restaurant and in town, and you hear that another pizza restaurant is moving in. And you think, okay, well, how is that going to help me? Well, it's probably going to steal some customers away from you. So if you think about what's going to happen to demand for your pizza when another restaurant enters the market, your demand for your pizza is going to decrease. So if we're thinking about a residual demand curve that's faced by a firm, a monopolistically competitive firm, if there's entry in the market, let's call that D1, entry will cause that residual demand curve to shift to the left to D2. There's the effect of entry. On the other hand, if you own a pizza restaurant and you hear that one of the other pizza restaurants in town is going out of business, they're going to exit the market, you're probably going to think to yourself, well, that's good. That means that I'm going to get some of their customers. So if we think about a demand curve like D1 and we have exit from a market, then that's going to shift the residual demand curve that you face to the right, to D2. There's the effect of another firm exiting the market. So entry and exit of other firms from a market affects each firm's residual demand curve that's in that market. Now let's think about that for a second, because if you think about it, you may remember that we talked about the determinants of demand, the things that shift a market demand curve. And the determinants of demand are prices of related goods, income, consumer expectations about the future, consumer tastes and preferences, and the number of buyers, the number of buyers in the market. And here, notice what we're changing is the number of sellers in the market. So you might, if you remembered those determinants of demand, you might say, well, wait, why is a demand curve shifting when the number of sellers changes? Because the determinant of demand is the number of buyers. Well, that has to do with the fact that we're dealing with a residual demand curve, not a market demand curve. So when we're talking about just a plain old market demand curve, the number of buyers changing, that's the determinant of demand. But if we're talking about an individual firm's demand curve that it faces, a residual demand curve, then the number of other firms in the market does shift it, along with the other 5 determinants of demand that we talked about. Okay, so let's talk about a firm that's earning a positive profit. Let's draw a picture of a monopolistically competitive firm earning a positive profit. The way I'm going to do this is I'm going to draw my marginal cost curve. I'm going to put my average total cost curve down here. There's average total cost. I'm going to draw my my residual demand curve like this. So up above that average total cost curve. So as you work along with me on this, draw your demand curve up above that average total cost curve, but don't worry about where these intersections end up being. That's not important. Go ahead and draw your marginal revenue curve that corresponds to this demand curve. Again, don't worry too much about these intersections. That's not what matters. The intersections do matter, but don't worry about how you draw it. Just put it on there. Now, we're going to call this demand curve D1 and marginal revenue curve MR1. And let's figure out where this firm's going to start. So we want to look where marginal revenue equals marginal cost. That's right there. So find that on your picture where your marginal cost curve and your marginal revenue curve intersect. Put a dot there. And then that tells you your quantity. Label that quantity Q1. And then from that quantity, go up to that demand curve. Put another little dot right up there. And then go over here and call that P1. And label that dot point A. So you should have a picture that looks somewhat similar to mine. Your intersections might be a little bit different. Your average total cost curve may be down lower. It might even be up here. It's not that important. This gives us a starting point. So this is a monopolistically competitive firm that's going to be earning a positive profit, and we know that because right up here's the price, and the average total cost, let's put on here, the average total cost would be right there. I'm going to call that average total cost 1. The area of that rectangle is going to be the profit that that firm earns. Now, in the short run, that's fine. This firm can earn a positive profit, but what's going to happen in the long run is that other firms are going to enter. So that positive profit is going to attract entry from other firms. And as other firms enter, we know that entry causes a firm's residual demand curve to shift to the left. So this residual demand curve is going to start moving to the left. I'm going to draw another residual demand curve a little bit to the left of this one. So I'm going to draw it about like that. So in your picture, you need to draw your residual demand curve a little bit to the left. And you may need to be careful about how you draw it because you don't want to draw it enough to the left that it's now under that average total cost curve. So we get a shift to the left of our residual demand curve now to D2. And when that residual demand curve shifts to the left, the marginal revenue curve goes with it. So my marginal revenue curve is also going to shift to the left to marginal revenue curve 2. Now, that picture's getting complicated, but here's what we need to do. We need to look at where my marginal revenue curve, my new marginal revenue curve, and my marginal cost curve intersect. And that, in my picture, happens right there. Now, it's just a coincidence in my picture that that's where my average total cost curve goes through. So don't worry if your average total cost curve's down here or even if it's up here. It doesn't matter. So I'm going to label, there's my new intersection. I'm going to label that Q2. So we see that entry is going to cause this firm's residual demand curve to shift to the left, and this firm's now going to sell less output. If this is a pizza business and another pizza restaurant moved into town, yeah, this pizza's restaurant's going to lose some of its business. Go up from that quantity Q2 to the new residual demand curve D2, and in my picture that happens right there, and then go over here and label that new price P2. And I'm going to label that point B. When that residual demand curve shifts to the left, the firm produces less output and it's able to charge a lower price, or it has to charge a lower price. It's not able to get as much for what it sells as it used to because it's now got more competition. And my average total cost curve, my average total cost of Q2 is going to be pretty darn close to where average total cost 1 was. There's my average total cost 2. You can see that the amount of profit that the firm earns is now smaller. There's no way that they could earn more profit than they did before if their residual demand curve that they face has shifted to the left. So what you can see is that if a firm earns a positive profit, then in the long run, other firms are going to be entering and that profit's going to be going to zero. Let me draw you quickly a picture of what it looks like when a monopolistically competitive firm earns a zero profit. So we've got a marginal cost curve. I'm going to go ahead and draw my average total cost curve here. Average total cost. What will happen is that entry will continue until the residual demand curve shifts to the left enough that it ends up being just tangent to that average total cost curve. There's going to be the firm's residual demand curve. Right here is going to be the price, quantity, and our marginal revenue curve will come right down through here. That's what the picture looks like for a monopolistically competitive firm earning zero profit. That would be the end result. If I kept shifting this residual demand curve to the left, I would need to shift it until it ended up being just tangent to that average total cost curve. And what you would see is that the price and quantity would converge right on that point of tangency. And we can verify that profit equals zero, because if you go up to this quantity to the average total cost curve, you hit the average total cost curve right at that point. So price and average total cost are equal to each other. That, of course, is why profit's equal to zero. So in a monopolistically competitive market, the firms are price makers. They have some market power, but they're not able to turn that market power into positive economic profit in the long run. If they earn a positive profit in the short run, it gets driven to zero in the long run. Now remember, that's economic profit. That is not accounting profit. Okay, so keep that in mind. Let's ask this question. This is is profit equal to zero inevitable? Well, its entry is going to be continually driving profit to zero. There are two things that are under the control of the firm that the firm might be able to change. The first is the firm could try to shift its residual demand curve to the right, or the firm might be able to become more efficient and reduce its average total cost curves, or all of its cost curves. If it could do either of those things, if it could shift those cost curves down or shift that residual demand curve to the right, it could make its profit positive again. But here's the problem. If it does that, there will be entry in the long run, and that will get driven to zero again. Let's talk first about how it might try to achieve each of those. The easy one is to think about its average cost curves and its marginal cost. Becoming more efficient, that's how you shift your cost curves down, but there's a lower bound on how efficient you can become. And it's challenging to keep costs down, especially if you've got incentives for your employees not to keep costs down. We talked about that in a previous video. Sometimes firms will set up a compensation program where the employees do not have an incentive to be careful about costs of production. And that can be particularly challenging for a monopolistically competitive firm. This, shifting that residual demand curve to the right, this is where you tend to see most advertising done. So firms will have an incentive to try to advertise. And this advertising is typically what we call comparative advertising, where if you're a pizza place, what you do is you run ads talking about why your pizza is better than everybody else's pizza. That's comparative advertising. Happens a lot in fast food, but you see it in a lot of other types of products as well. The question is, how much advertising should a firm engage in? And the answer to that at the most basic level is that you engage in the amount of advertising where the marginal revenue from advertising is equal to the marginal cost. That's always how the optimal amount of something is determined. We're not going to get into that. That would be, you can go into more depth on that, but we're not going to worry about that in this class. It's also the case that one way that you can try to shift your residual demand curve to the right is maybe come up with new products. So there was a time when nobody had put cheese in the crust of a pizza, and some pizza restaurant, I don't know who it was, probably Pizza Hut, was the first business to have a stuffed crust pizza. The problem for them was that everybody can put cheese in the crust of a pizza. So you might have a new product for a little while and it might shift your residual demand curve to the right, but as soon as everybody else is doing it, well, that advantage that you had goes to zero. There's one last thing that I want to cover, and that is that your book talks about what's called the profit maximizing advertising to sales ratio, and it uses the amount of dollars spent on advertising to the amount of sales or revenue that you earn. And it's fairly easy to show. I'm not going to do it. We don't need to worry about it. Why this is true. We don't need to derive the result. But it's easy to show that the profit maximizing advertising to sales ratio can be found by looking at the elasticity, the advertising elasticity of demand, divided by the own price elasticity of demand. And we talked about, so here's our advertising elasticity of demand divided by the price elasticity of demand. We talked about those in a previous video. And again, we don't need to worry about deriving that. But it's a challenge in a monopolistically competitive market to try to continually keep your costs low or try to continually shift that residual demand curve to the right. And if you're not able to do that, your profit's going to be driven to zero. So the answer to this is profit equal to zero inevitable? Yeah, for most firms in this type of market, it is. So that gives you an idea of three types of markets: perfect competition, monopoly, and monopolistic competition. Monopolistic competition is easily the most common type of market, and what we're seeing is that profit gets driven to zero. You have to remember that's economic profit. What we still need to do is we still need to talk about oligopoly. That's the last type of market, but we're going to do that in another video, so I'll see you there.